What if the future of rail was a hybrid of legacy and innovation? In Alberta, an industry-leading project is transforming the freight sector as we know it. Canadian Pacific Kansas City, or CPKC, is developing a hydrogen locomotive program to help decarbonize its operations, moving beyond traditional diesel fuels. This innovative project leverages decades of Alberta's oil and gas expertise, marking a significant step towards a new era of low-emissions transportation. The goal? To replace diesel-electric systems with a hydrogen fuel cell and battery, aiming for a cleaner, more efficient, and ultimately zero-emissions future for freight rail. With funding from ERA, CPKC has been able to expand its hydrogen locomotive fleet and test the technology in real-world 24/7 operations. ERA's support has helped the company prove the technology's viability and establish a reliable hydrogen supply chain right here in Alberta. After a successful demonstration of the Hydrogen Locomotive Program, CPKC has partnered with CSX Transportation, a major U.S. Class I railway. Together, they formed a new joint venture called Hydrogen Technologies. Kyle Mulligan, who led the development, now serves as president of Hydrogen Technologies as they aim to scale and deploy the program across the North American rail network and beyond. We sat down with Kyle Mulligan, Assistant Vice President of Operations Technology at CPKC, to talk about the inspiration behind the project, the lessons learned from early challenges, and what the future holds for this transformational technology and the locomotive industry. Here on Carbon Copy. I'm super excited that we're doing this podcast because I think, as you know, this is a project that I'm very excited about. So glad that we'll be able to highlight this. So you have had a super exciting journey with this technology, and you've had a front row seat in what I think, and I'm sure you agree, is going to be a huge transformation in the rail sector. And so I'm wondering if you could just start by talking us through your personal journey with CPKC and the Hydrogen Locomotive Program.
Yeah, my personal journey with CPKC started almost 12 years ago. I joined the railway. I was living in Eastern Canada, applied one night, got offered to move out to Calgary, and really, I would say that's where my adventure began, working for the railroad. Not many people know it truly is an exciting business. We're 24/7. We operate trains across from coast to coast to coast through all kinds of different climate conditions, all kinds of struggles. And, there are thousands of problems to solve every day. And, I immediately qualified after 1 year of starting at the railway as a locomotive engineer and a conductor. So not only was I a technical engineer with a doctorate degree in mechanical engineering, I was able through the railway to get trained, to get hands-on experience to understand how the operation worked. And very quickly through that experience started identifying problems where we could become more efficient, we could control our costs, but more importantly, operate safely. And so my main role initially was to use data, analytics, and technology to keep the trains and the rail cars and the locomotives on the tracks and get from point A to B as efficiently, quickly, and safely as possible. And, through the first 5 years of my career, I focused on that, and it did catch the attention of our leadership team, and more importantly, our chief executive officer. And through another series of unfortunate incidents, was able to get quite a bit of capital investment to inject more technology into the railway, which resulted in something that we call broken rail detection for our non-signal territories of our network. So areas of our network, about 50% in Canada, where we just have nothing but track and ties, no intelligence, no signals, nothing. And we were able to develop as a team an off-the-grid solution that cost a fraction of what our traditional systems from our traditional suppliers cost, and we were able to roll it out across our entire network in 4 years. And that has virtually eliminated broken rail train accidents. And why I highlight that is because that was what ultimately was the impetus or the trust building type of scale project, which then when we got into climate change and solving for climate change, had that credibility of our CEO to make such an investment, an initial investment in hydrogen fuel cell battery locomotives.
Yeah, thanks for that. I don't think I'd heard that story before, and kind of, especially when you're dealing with a new fuel, having that history lends a lot of credibility. So that's really cool. And before we dive into your current project, I thought it would be good if we could give listeners a quick overview of how CPKC got started with hydrogen power locomotives in the first place. What kind of led to that?
Yeah, so in the beginning was really we have a number of investors, mainly European investors, who wanted to discuss with my former leader at the time, who was our senior vice president of mechanical and engineering, what our strategies were for solving climate change. And he was and still is a very smart man. Is retired now, also an engineer, very well versed. Starts showing the presentation of how we save diesel fuel and how we have energy management systems on board and how we configure our trains and how efficient rail already is. And these investors, for the first time, I think in his career, stopped him in his tracks and said, no, respectfully, we want to know what solutions you have to create or alter your business so that you're actually not burning or relying on fossil fuels, period. And, he said politely, well, I don't have anything like that in this deck. And, quickly was given another opportunity to come back to the office and then in a month's time present. And, he gathered the troops and we started giving our inputs. And, some of the leaders did what, normal leaders would do, went to our supply chain, our old faithful rail suppliers, said, what do you have in the hopper? What are you working on? What's exciting? And I blurted out in the meeting, I said, why don't we skip over biofuels? Why don't we skip over battery electric and just go right to hydrogen? It's a portable fuel source. There are pathways to generate it cleanly. You can really structure a 20, 30 year capital program around this. But what we're missing is the real demonstration of a line haul locomotive and revenue service. And I think we could actually rebuild one. And like we do today, we modernize and rebuild existing diesel locomotives. And I'll tell you, blurting that out, that's the one time in my career where it was all of a sudden, the room stopped and it's like, yeah, let's do that. So then I got an opportunity to get on the business train, actually, ironically, out of Lethbridge. Our CEO happened to be in town and was doing what we call inspection trips. And pitched the idea, and at the time he also wanted to see our broken rail detection system that I just mentioned. And so I was able to show him, an alert text message that we were getting while we were on the train, showing where we were and that the track was okay. And then when we stopped, we had a dinner, and I said, look, sir, I want to build this thing, and I think we can do it, and I think we can do it internally, and I think it will send the right message to the industry. And I think it will give our investors something to look forward to. And that is where he said, I will let you build one. And I have said that in a video that you'll see on our innovations page or on social media. And it is the truth. That's exactly what he said. And that was truly the beginning of the program. And, we'll talk a little bit probably more about this, but that's, once we started that program, it also became about, well, one isn't really satisfying enough. Let's build it, let's show it, let's do what we said we're going to do, let's get it into revenue service. But how do we, what's next? And that's where Emissions Reduction Alberta came in, and that's where our relationship started.
Super exciting. Yeah, we have more than one now, a few more. So, that's kind of like one of those pivotal career moments that you'll probably always remember. So that's a cool story to that. And I think also it's neat because a lot of people don't think of rail, and especially freight rail, when they think of climate change, mitigation and zero emissions vehicles. So Super exciting. And so you alluded to this a little bit, but I think when we think of zero emissions vehicles, and in the context of rail, even people probably sometimes they first think of battery electric. And so I'm just curious if you could elaborate a bit on what made hydrogen an attractive option as opposed to battery electric or other alternatives.
Using diesel, we've gotten very good over the last 70 years at optimizing our entire operation. We optimize how we fuel the locomotives. We actually bring the fuel directly to the locomotives. We don't take the locomotives necessarily to a fixed point location to refuel them. We do have those as well for our mechanical shops because there are opportunities to fuel at those locations. But when a locomotive is in a freight train, it's going across the country, the most efficient is to bring the fuel to the locomotive and then fuel and keep going. And so we have also optimized the number of locomotives we use per train. We know based on the grades, the curvature, the reliability of the locomotives, the number of cars in the train, we know how many locomotives are required to move that across the country. And we have data streaming into our back office, monitoring these assets to make sure that we can essentially assign the correct number of locomotives to that train, nothing more, nothing less. But now that we've done that, and now you're entering with an alternative technology, you need a technology that will ultimately replicate that so that you don't have to modify your entire operation. And hydrogen, in our view, provided that flexibility that I just mentioned. One of the biggest strengths of hydrogen is the ability today, present date, to fuel the locomotive from a truck, just like we do with diesel. That allows us to use the fuel cells, which are essentially acting like onboard generators, to recharge the onboard traction batteries. We don't need a catenary system. We don't need a fixed recharging location. And you have to keep in mind a single medium horsepower locomotive. So I'm talking, between 2,000 to 3,000 horsepower. We run as high as 4,400 horsepower. Is essentially 40 electric cars in one platform. So if you're trying to recharge 40 electric cars, but you've got on average 15 locomotives in a terminal, you can see that it doesn't really scale. But hydrogen, you can implement the infrastructure, so you can generate it within your own yard. Then you can transport the hydrogen to where you need it, or you can have the hydrogen manufactured in a centralized refinery, let's say, or a production facility like Edmonton, and then you can have it transported to you. And then you don't have to be in the production business, but you can utilize the hydrogen. You can get it to the locomotive. So, for us, it was always part of the equation from day one. We could not. There was not a battery on the planet that had enough energy density based on the tonnages and the duty cycles that we operate that could essentially fit right into the operation without us having to, duplicate or even quadruple the number of locomotives. And so when you quadruple the number of locomotives, you quadruple the regulatory inspections, you quadruple the maintenance. Essentially, it cripples your operation from an efficiency standpoint.
Yeah, that's helpful. So hydrogen is essentially a slot-in for diesel, except for zero emissions for these 24/7 heavy-duty operations where hydrogen is more energy dense than even the best battery in the world. So what I didn't realize when I first learned about this project is that locomotives are actually already electric vehicles. They're diesel electric. So you're switching to a hydrogen-powered fuel cell electric vehicle. So can you just explain a little bit about how it actually works, how it actually runs, what's under the hood, so to speak?
Yeah. So you're right. So diesel electric locomotives are already hybrids. So trains, they have an onboard diesel generator that turns an alternator and generates power, which is fed into electric traction motors. What we've done with the hydrogen fuel cell battery conversions is we've taken the diesel generator and alternator and existing cooling system, and we've removed those components. But we've maintained the same electric traction motors that the locomotives originally used. So everything from the bottom deck down is locomotive. And in fact, approximately 60% of the original platform is the same and reused. And so it's we are converting these locomotives, or what we call modernizing these locomotives, which is an existing industry practice on the diesel side. So what we replaced the diesel generator with are hydrogen fuel cells, and we replaced the former fuel tank area with lithium batteries. We also have to, because we're using hydrogen on board, we have pre-assembled skids of hydrogen cylinders that hold the fuel, essentially compressed gas. The fuel cells, they electrochemically react hydrogen with oxygen through a membrane, and that reaction produces heat, electricity, and water vapor as an exhaust. We can use that electricity, feed that into the existing locomotive traction system or a modernized version of it. You can also use the battery power and feed that into that same system. And in low power applications, the fuel cells are charging the batteries. The batteries are providing power to the traction system to turn the electric traction motors and ultimately turn the wheels and apply traction to the track. And then in higher power applications, actually the fuel cells and the batteries are blended together, so they're both producing power. And why, a big part of why we used fuel cells as well, or something that was very attractive, is that they weigh significantly less than batteries when you compare the amount of power versus volume that they can produce. And because we're modernizing these frames and reusing frames of existing locomotives that are, people say in our industry they were overbuilt and they can basically outlast all of the other components on the locomotive, we needed to keep the weight the same, basically. And so our fuel cell battery locomotives essentially weigh the same as the original platforms. And so that's another reason why we didn't have to redesign a brand new frame or car body, and ultimately a whole new locomotive.
Great. Oh, that's super helpful just to understand how the technology works. And going back to what you're saying about the technology being developed in Calgary, I think one of the really exciting aspects of this project is how much of this entire technology is made in Alberta. And I know one of your key partnerships for the project has been with Built-In Manufacturing, which is actually based in Innisfail. So I'd love if you could tell us a little bit about that partnership and how that basically a local company in Innisfail has supported the development and evolution of this really transformative technology.
Yeah, absolutely. So, when we first started the program, we very quickly realized, we had a first initial fuel cell, and we had to demonstrate to our CEO within 42 days. We were provided to say, okay, take this fuel cell, take a hydrogen supply, and basically turn a motor and show me that you can do this. And when we started, you could buy the fuel cell, you get it, and then how do I? There's electrical connections, there's hydrogen connections, there's cooling connections, and you very quickly realize that half of these locomotives are like an oil and gas plant. You have heat exchangers, you have stainless tubing, you've got pressure vessels, you've got cooling systems and lines and so on and so forth. And so we needed help, and we reached out to Built-In in Innisfail and toured the facility there and realized that there's a significant expertise there in this type of work. And so we had the expertise on the locomotive traction side, the wiring side, the mechanical side, but we didn't have a shop to be able to put it all together. So we needed cranes, we needed people, we needed welders. And Innisfail just seemed like the absolute perfect location to do this. It's an hour and a half north of Calgary. They have highly skilled individuals and leaders that can, build massive pressure vessels that are used in Alberta. They have, as I mentioned, the expertise in oil and gas. And so that combined experience, we were able to build that prototype that I just mentioned of showing our CEO that we could get a fuel cell to work. But ultimately that led to building the entire locomotive. And what we learned through working with Built-In in Innisfail was that very commonly in the Alberta oil and gas industry, a lot of components that are used in the field are assembled into these pre-assembled skids or pre-assemblies. And Built-In really brought this innovation to us to say, well, instead of assembling these component by component onto the locomotive, which is what a typical traditional OEM would do, what if we assembled these on the shop floor into these skids, stripped the top of the locomotive of all the components, dropped the skids into the locomotives, put the car body on top, and then commission the locomotive. And what that allowed us to do was take significant costs out of rebuilding these locomotives. You'll often hear a lot of podcasts in particular about hydrogen fuel cells and zero emission components and assemblies and vehicles being way more expensive than your traditional fossil fuels based equipment. But if you innovate in terms of, well, how can I rapidly convert these? How can I assemble these skids, test them, commission them on the shop floor, drop them on a locomotive, get the locomotive refurbished and send it out the door? You can actually, we're actually at parity from a cost perspective with a Tier 4 diesel low horsepower locomotive today, right now, in 2025.
Yeah, and it's such a great example of how skills from the oil and gas sector are translatable to a totally new technology, and also super impressive. I didn't know that they were at cost parity, so that's exciting. And yeah, not something you hear very often. So I wanted to switch to talking a little bit more about the ERA funding support. So we've been working together for a little while now, and you said when you started this off, you were allowed to build one. ERA funded an initial project where we built two more. And then more recently, ERA is supporting your second project, the Alberta Rail Terminal Decarbonization Project, which is actually almost complete, which is hard to believe. You guys are just working lightning fast. So if you could tell us a little bit more what the latest round of support allowed you to do, building on the previous project that ERA supported.
So when we built the first 1001 prototype, again, I talked about these pre-assembled skids. We did our best to sort of build the locomotive in that way. The 1001 came together. With any startup, there seems to be a bit of luck in all this because, we started it, commissioned the fuel cells, started testing, you go through the growing pains, you hope you can solve these solutions. And at the end of the day, you do, but you look back on the locomotive a few years later and you're like, we can do better. And if we're going to scale this up, and, originally the pilot was to help try to convince the industry to move forward with the transition and move quicker in terms of what we're doing as an industry. But we quickly realized that, we're going to have to continue to do it. It's the right thing to do. It's within our company culture. We can't force others to do what we're doing, but we believe in this. And we got we wanted to see, well, how could we scale this up, but how could we protect the employees we hired? How can we protect the knowledge, the technology, and the momentum in the program? And that was the first tranche of funding that we got with ERA to build two different types of variants. So we built those, we got those into service. We showed this could work, but we didn't really get the finesse of it all still. We got a single, we got it down to two modular skids. We didn't have quite the capacity that we wanted. And so we applied for additional funding to say, how can we build these pre-production models that have a unified skid that go together quickly, where we could demonstrate that we can meet the cost parity that I talked about. And can we deploy them into 24/7 service with the mission they're designed for, and are they reliable? And can they feasibly replace a diesel electric locomotive? And can we do this in Lethbridge? And that funding essentially was to achieve that. And it's taken hours and hours of discretionary effort and refinements and lessons learned. And I'm happy to say, the units are running right now as we speak. Like they're out there doing their mission. And I continue to look at my phone for notifications to see if anything's not doing what it should, because we have remote monitoring and everything seems to be working fine. So, and that is now thanks to that project, and we'll talk about it, but that's essentially led to the establishment of a joint venture. But that joint venture that we'll talk about has a commitment from CPKC to build even more on an annual basis and scale this up further. So I would say if, without that funding, we wouldn't have been able to demonstrate revenue service deployment. We wouldn't have been able to convince all of the various internal departments that these locomotives are reliable, that we can build them at a reasonable cost. We can put in the hydrogen infrastructure to be able to fuel the locomotives, which in Lethbridge is being supplied by Air Products. So we're not, unlike the previous program where we're generating our own on-site hydrogen. It gave us the opportunity to establish a supply chain of hydrogen within Alberta, where we could get blue hydrogen generated in the Edmonton region and delivered to our terminals within Alberta.
Well, there's like a lot I want to tap into there, but I mean, first of all, just like project being completed on time, on budget, I think is a real accomplishment that should be celebrated. As a funder of innovation, we see many projects that are not on time, on budget, and so that's a real accomplishment for you and your team, Kyle. And then just for our listeners' benefit, so the first ERA project involved the hydrogen supply was coming from two different electrolyzers, one powered by solar and one powered by the grid. So kind of showed electrolysis-based hydrogen. And then more recently, there's that Air Products partnership that's supplying that direct-to-locomotive refueling that's probably more similar to what a commercial system looks like and ultimately will come from blue hydrogen. And so that's been really exciting to see in that second project. And then you've talked about the joint venture a couple times, so I think we need to get into that. And so maybe we talked about Bilton, how they're building these kits that are kind of set on the locomotive frame, and then there's this modernization piece to that. And so maybe you could tell us a little bit about this super exciting partnership and joint venture with CSX.
Yeah, so CSX Transportation is a major Class 1 railway in the United States. They operate along basically from the Midwest to the East Coast, and I think they're tied with Norfolk Southern as the third and fourth largest Class 1 railways. And they ultimately reached out and wanted to come up to Calgary to see these locomotives. And they also believed in what we were pitching in terms of using hydrogen as an alternative fuel source, and they operate in a very similar way that we do. Immediately when they came up to Calgary and they went for a ride in the locomotives, they actually left same day, and I got a call the next week saying, okay, let's get a letter of intent going and let's build one together. And by the way, we need you to come down to West Virginia because we have a facility, a modest facility. It's about 7 football fields worth of covered shop space. And we modernize all of our locomotives internally. We strip them right down to the bare core frame, and we build them right back up. And we think that the conversion kits that Bilton has put together, we could integrate those and we could come out with a higher quality locomotive. So because Innisfail doesn't have the same expertise on the locomotive side, so when we talk locomotive side, you have the electric traction motors, you have the trucks, you have the air brake system, you have the air dryer system, you have the cab, the lights, the number boards, all kinds of peripherals, the bell, the horn. And on the early generation locomotives that we were building, as good as they were, we were getting reliability issues because we weren't modernizing and rebuilding the entire locomotive from the frame up. We just didn't have, from a budget standpoint, from an efficiency standpoint, we just didn't have the tools and the equipment and the production line in place to be able to do that. And so that's where we, went out to Bilton and said, we think this makes sense. We think at the end of the day, we'll have a brand new, refreshed, fully modernized locomotive. We won't have failures or reliability issues because all the components will be brand new. Plus, because this facility in West Virginia has the ability to move locomotives through, it's around 27 different bays. We could actually, when we look to modernize 15 to 30 of these a year, we need a shop that can really scale. And so we formed this joint venture partnership. And so how it works is we still continue to build the kits. We maintain the expertise, the intellectual property, and the know-how right here in Alberta. Our staff are right here as well, Innisfail staff. And so that investment, we've basically protected the new stuff. And CSX has come to the table and said, well, we can help you integrate it better, and we can basically roll off a brand new locomotive off the assembly line. And so now we have a product. And so that combination, became a joint venture that's called Hydrogen Technologies. And, it's a 50-50 joint venture between CPKC and CSX. But essentially now, through that JV, we can supply these locomotives to the entire industry inside North America, but also outside, on a world scale. So what it's become, and our first locomotive just rolled off the line last month, and it's arriving here in Calgary. I can't wait. I'm tracking it every day. It's 3 days away. It's on one of our trains moving out of Toronto. But it's just become, you can tell when they're side by side that that one looks like an absolute brand new locomotive. And I think we're going to get significant reliability out of these. I think this is an absolute challenger for a low horsepower diesel locomotive. And it's thanks to all the hard work and the good work. Obviously our first ERA unit's impressed because we attracted that attention from a major U.S. railroad. And trust me, I've worked with these folks long enough that they'll tell you what they think. They won't hide it. So, we're pretty proud of that. And now it's just made the program so much better. One of the big innovations too at the shop is, we have enough onboard hydrogen in our low horsepower locomotives to last a week before we have to refuel, which is essentially what we top up our diesel units every week as well. So the fact that we can run that mission, and we will be running that mission in a month here in revenue service in Calgary, fueled by green hydrogen from our electrolyzer, it's just, completes the square basically, right? It's amazing to think that we're just around the corner from achieving that.
Yeah, congratulations and congrats on the joint venture. And yeah, I think what's compelling about this is that a lot of the IP and the technology remains in Canada with Bilton and with the partnership that you've built with them. But this new partnership with CSX allows you to scale and have a product, like you say. So, so thanks for walking us through that. So I can't imagine that you've been through all this and not had any challenges. So I want to switch to talking about challenges and lessons learned, and maybe I'll just open it up. What are some of the tougher hurdles that you've faced, whether it's technology, operational, or otherwise in terms of scaling up this technology?
Oh, where to start? Yeah, it's not all roses for sure. One of the biggest challenges early on is, with anything that you're just starting up new, you have an allocated amount of money. We're not an OEM. We're a railway operator building our own locomotives. So you're allocated a certain amount of money. That's it. That's all you get. Don't come back to the trough. You said you could do it for this month, this much. And so mistakes, you're doing this design for the first time. I'll never forget the first battery box we built and how square it was and how it didn't quite fit the clearance envelope. And one day we're moving through downtown Calgary and we scraped the passenger platform there, and it's like, oh, okay, so where else is this going to touch something? It hadn't touched anything to date, and 6 months into testing, you see this, and it's like, okay, that battery box plus all the batteries weighs 12,000 pounds. What are we going to do? We don't have enough money to strip this apart. So what are we going to do? And you get people together, you do HAZOPs, you do risk assessments, you put in rules and restrictions and things like that, but ultimately you want to make sure that you don't keep doing the same mistakes. So making sure that you get this list of things that you want to correct, making sure that your people follow through on it and your leaders are driving. And you can't solve all the risk out of everything. It's impossible. Even the best designed things out there have challenges. That what you really want to make sure is that nobody gets hurt, from the employees on board to the employees working on the unit to members of the public. But at the end of the day, things are gonna fail. You can't design the perfect locomotive on paper. You never will. And so, having to be there as a leader, it's scary because you have to make decisions for people sometimes and to keep the program going. And that, I still look back and as a leader, I think you're always trying to reevaluate how you lead. And, was that the right decision? Should I have just said in the minutes, yes, we're doing it. And, even though, there were certain concerns and, as a leader, you make mistakes too. So just sifting through all of that and, staying up at night and thinking through all that, it's innovation is not easy. Anybody, you can have 1,000 ideas, but getting one of those 1,000 ideas into production, supporting it after it's out there, recovering from mistakes. I've always said innovation is not for everyone. So you have to follow through. And I guess, the other piece too is when you're operating these locomotives out on the main line, how you respond to challenges and failures, how you recover from them, how you maintain openness and transparency, and how you develop that support of people who will help you when you fall down. And we have Calgary Terminal, Lethbridge Terminal, Clover Bar, and Golden, and our operations leaders, they know this isn't going to be perfect right out of the gate. They know there are going to be growing pains with all these technologies, but they need to know that we're not going to have an issue and sit there for months thinking about the issue. We're going to be boots on the ground. We're going to be present. We're going to be leading there at the field level. And that takes a lot of hours. It takes a lot of time away from your family. I have a wife and daughter, and you have to have that family support. And when they get that call, hey, I'm gonna have to head to Lethbridge, or I'm gonna have to do an overnight here in Calgary because things are just not going the way we need them to, and we're testing back and forth. We can't figure out the challenge, the problem. Is it a connection? Is it software? But it gets very emotional because you think back through. And then, the last thing was, quantity over quality. Everybody, you always think having more people in the project is better. And what we realized is we scaled up people-wise very quickly, but we actually got less efficient. And I think, to a large part, that was my responsibility because, you got to get people in the door, and you can't spend hours and hours interviewing and so on and so forth. And it wasn't that we just had bad people, but in when you're in a startup and you're in sort of this this type of project, you need people that are going to be there, discretionary effort, after hours, give and take. You try not to burn anybody out, but you know that when you're in the field, it's going to be a long day, several days probably. And what we had to do is sort of look at the team, and as we changed from an innovation team of building a locomotive and we started standardizing on the design and the platforms and scaling, we very quickly became an operations team. So when things happen, you got to be there. You got to support it. You've got to be able to recover quickly. You can't spend months thinking about changes. You've got to put those changes into action. Now that I look back over the last 5 years, it's like, our team culture actually had to go through this major shift. And I wouldn't be surprised if other folks who have started projects of this scale and reach success would say that they've gone through something similar.
Obviously, I know you're coming at this from a leadership perspective, but also it's obvious you've been through the trenches and have had many of those late nights, and you gave a lot to unpack. And but I wanted to talk about the safety aspects a little bit, just because I know that's something that comes up often with hydrogen. And, you're dealing with a new fuel, and a lot of that regulation may or may not even exist. And so I'm curious if you could talk through what are some of the key differences between these new locomotives you're building and diesel locomotives in terms of safety and regulatory and that kind of aspect to it, or even just training like you were alluding to.
Absolutely, great question. So from a safety standpoint, we have to have a respect for the gas. It's hydrogen gas. There are known protocols that can be put in place around proper grounding when fueling, hydrogen gas monitors on our staff, and limiting combustible sources around the locomotive, and then on board the locomotive. Active LEL detection. We set our LEL detectors well below the 4% limit. We're at 1% because any leak is a no-go for us, and so that's all tied into the control system and the operators are alerted and the control systems go through a soft shutdown. We also instrument the locomotives with fire eye cameras as well, because hydrogen burns invisible. We also want to make sure our power electronics haven't shorted out or are arcing, and we have ground fault detection on the locomotive if we have any form of short circuit. Regulator is the one I kind of want to focus on. So we've done all of that work. We've done over, I think we're on our 8th hazardous operability study as well. We've hired third-party consultants to come in because we want to be cognizant we're a railroad. And yes, we have, including myself, we have professional engineers working on this project who, we have a duty and an obligation to make sure that we protect public safety, including our own lives. But we also have quite a bit of safety systems. I think people overlook battery safety. I mean, batteries, if you had a thermal runaway, we use an NMC chemistry in our batteries. There's nothing putting that fire out. You have to keep it cool as long as you can and essentially let it burn out. We have different emergency response techniques and training in place for that. So I think the other part of your question is you're building the locomotive, you're trying to get that to work right, you're building the infrastructure. Oh yeah, and then there's all this emergency response stuff you got to build and maintenance procedures. So it's a lot of work. But the regulator is the one I want to focus on. So we took the approach right off the bat, early engagement with the regulator. Look, we're doing this. The current locomotives that we've refurbished, they meet all the current rules. But obviously the elephant in the room is they use a very different propulsion system. So we've engaged with Transport Canada and the Federal Railroad Administration because we've deployed these locomotives primarily in Western Canada. We've had a lot of dialogue with Transport Canada, and we've submitted hundreds, if not thousands, of pages of documentation. And when we did the high horsepower program, we realized that we needed a tender car to increase the capacity of hydrogen that we were building. So it's essentially a freight car that's designed with crashworthiness considerations, but it holds up to 2,000 kilograms of hydrogen gas. And the reason is because we need more fuel because we have a lower energy density in comparison to diesel, and we're going over much greater distances. It turns out in the Canadian regulations, hydrogen is a dangerous good, and if you have it in a rail car, you require regulatory approval, and that comes in the form of an equivalency certificate. So they want to look at the method of containment. How are you containing the gas? Does that meet standards outlined in the Canadian Standards Association? Do you have any designs that don't have any standards, and what are you doing to ensure that those are safe? And so that regulator engagement with rail safety and transportation of dangerous goods has been happening over the last 5 years. And I am pleased to say that has led now to a special project where they've developed what they call a regulatory sandbox. And essentially we are now crafting rules and regulations for these locomotives so that the local inspectors, when they come and inspect these locomotives, have guidelines and they're validating that we're doing what we said we're going to do. And it's a continuous learning, but and we know full well at the end of the regulatory sandbox there's going to be scrutiny of our design to say, well, you're using that valve or that sensor, you're routing piping this way, why do you understand the risks? And we'll see, it could lead to design changes, but overall it's our belief that will just enhance the product even that much more. And we're supporting CSX and the FRA, and we do have plans to deploy these locomotives into the U.S. in the near future as well. So making sure the Federal Railroad Administration is up to speed, and again, getting their inputs and working collectively and collaboratively is absolutely critical.
Yeah, and I think it's just important to recognize that all this is happening in parallel with developing the technology itself. So all part of the transition. And the last thing I wanted to just ask about in terms of challenges and lessons learned, because I want to make sure we have time to talk about the future, is on hydrogen supply, because that's another thing we hear pretty often around the hydrogen economy is chicken and egg supply of hydrogen. And this is something that I think you guys have really excelled at. You self-supplied your own hydrogen for the first project, and then more recently have this collaboration with Air Products for the direct-to-locomotive refueling. So I was wondering if you could share any highlights or lessons learned, particularly from that partnership with Air Products.
Yeah, well, I think the partnership has actually been beneficial on both sides, believe it or not. So what we learned from Air Products was really on the liquid hydrogen storage side, and then converting that liquid hydrogen into gas and dispensing it into the locomotives. The various components, standards, safety considerations, site surveys, we have so much work to do on the locomotive side. How can we get some help in doing that? And so, what we learned through that project, though, is that there is a certain way of how construction projects get done in sort of the utility space and in the oil and gas space. And then there's sort of like the railway way of how infrastructure projects get done. Normally if you're going to say, hey, I want to buy an electrolyzer, or I want to buy liquid storage and compression dispensing, and I want to install it, you can go to a utility or oil and gas company and they'll say, yep, that's great, we'll do that. Let's get some project management going, and in about 3 years, we're going to get it in the ground. And that's just kind of the standard way, and there's certain standards to do that. But through going through those first two electrolyzers and the openness of Air Products to really work with our internal facilities team, we were able to get those installations down to 12 months. We've been able to work with Air Products to really bring down the amount of time it takes to implement these. And of course, we're implementing them within our terminals. So we sort of know the lay of the land of the terminals and where the best place to fuel a locomotive is. And we use Air Products expertise to identify the hazards. So working collaboratively to figure out the best place for these sites is one of the big, it is a pretty big step in the project. And then the other piece too is Air Products is not only doing the fixed point fueling infrastructure, but they have done a significant amount of work around liquid to gas mobile refuelers. And so we're able to take the fuel, and these trucks have onboard liquid hydrogen, but they also have the evaporation, compression, and dispensing side of it. So if you get hydrogen, like say from a gaseous hydrogen trailer, the best you can do is fuel the locomotive up to 40%, because you're just cascading the high pressure hydrogen into the locomotive. But with these L2G refuelers, they've really changed the game, because you can actually get a full fill. You can compress that hydrogen right up to the locomotive operating pressure, and we get 100% fuel from them. So that was probably the biggest selling point for us with sort of getting a partnership with Air Products, was that mobility aspect, and just how much they've invested in the delivery and supply chain of hydrogen.
Cool. So it's really that kind of mobile liquid refueling technology that gets you to the point where you're really replicating your current operations with diesel, and similar fueling times, your direct to the locomotive. So it's a long way that's come, not just on the hydrogen technology, but I think also on the refueling technology. That's important to recognize. Okay, so we've talked about the ERA project. We've talked about your challenges and lessons learned. So what's next? What does the future hold?
Well, right now with CSX, we're currently building 20 additional low horsepower locomotives. So they're building 10, we're building 10 between now and 2027. And the idea there is to get them out in the operation, slam them around, and assess their reliability, develop and integrate maintenance procedures. And post-2027, with this joint venture, we actually have reserved production capacity, and you'll see very quickly that we're going to start scaling up the number of conversions that we do per year. Ultimately, all those locomotives are going to be deployed in Western Canada. So you'll probably see a fueling facility spring up in the Vancouver region, hopefully the Moose Jaw region as well. And then there are other sites within Alberta as well. One of them we've talked about is Medicine Hat. So, and then that's where the team's really going to have all these, we're kind of trying to set up a command center now to see where all the locomotives currently are and what they're doing and their health status, and we're getting alerts. So as fun as it's going to be, it's going to be, we're, welcome to the show. We're pretty much in the CPKC operation, and they have to perform. But this year, basically between now and 2027, should all of this work out the way that we're working so diligently to have realized, you're essentially looking at, the transition from, steam to diesel to this. And it's game changing. And, so there you go. That's what's next. So super excited about it.
Awesome. And I know one thing we've talked about in the past is, what does full scale manufacturing look like? Because as you have a pipeline, and that pipeline is, just going to grow. And so what does that look like for Bilton, for example, for Alberta, and the manufacturing opportunity there? If you could talk about that a bit.
Yeah, well, so right now, whereas we produce the kits in Innisfail, we're producing so many kits now. So we're at 10 a year basically, and you're going to see that transition to probably about 30 a year. We're moving things all kinds of directions around to create the space, and what we really need is we need a facility. We need a world-class manufacturing facility, and that's what we're targeting in Innisfail. We don't, we're continuing to chip away at it. We would appreciate and are trying to work with government to establish partnerships, the Township of Innisfail. But ultimately, I think we've got the production capacity on the modernization side. But, if you're asking what my vision is, and what I would, if, we always say internally, what do you want to be when you grow up? It's this, fairly sizable square footage facility that's LED lit, that's got solar panels on the roof, that's got blue floor paint, it's got yellow lines everywhere, it's got little carts going around, and it's got skids moving from point to point, and it's got fuel cell test cells, battery commissioning cells, so that the initial quality is all there, but essentially a production line. And I think it's entirely possible. I think Alberta's the place to do it. I think Innisfail's the place to do it. I think with everything we're seeing geopolitically, this is a huge opportunity for our country. I'm one of those people. I'm one of those Canadians that says, how come we don't build our own automobile in this country? I grew up with hearing that from my dad, and I get that we're 35 million strong, but when you have an opportunity like this is huge, right? And this is technology that the world needs. This is technology that matters. And doubling down, I should say, on this technology is absolutely the way to go. It will put Canada and Alberta at the forefront. And, you alluded to it earlier, Grace. I mean, this is not replacing oil and gas. This is using all of those lessons learned and putting it into action. All of the people that work in our current oil and gas industry in this province have a transition path with this type of technology. Their skills matter in this space. And so, that was a long-winded answer to your question, but that facility someday just off to the left of the number 2 highway is what we're trying to grow to. And I hope we get there.
Yeah, I think I'd love to see that too. And that would be such an exciting opportunity for the province. So after everything you've learned and built, after all that, what is most exciting to you about the future of hydrogen in the rail sector?
I just want to see it come to life. If this truly is the right technology and what we're putting out there, I want to look back someday and say I was a part of it. And I'm honored that I'm able to lead this High-On Technologies JV in the initial phases here, and that it led to this. So someday, looking back and seeing that, it was part of the diesel to something transition, and the technology gets adopted, especially if, we've got CSX as a customer and we have others interested. So, once we start seeing, other railroads adopting this, it's going to be just that next level.
Amazing. And is there anything else you want to mention before we sign off, Kyle? This has been super informative.
I just want to acknowledge the support of ERA. I think the model, we wouldn't be having this conversation if it wasn't for ERA. The model that you have, as I've said it in the past, I'll say it again, being able to supply grants and to industry and to groups like mine has really allowed us to realize and put our plans into action. I would also say I appreciate yourself, Grace, and Liliana and the team and David and the team too, that you're constantly engaged with us. You're bringing subject matter expertise to the table as well, and holding us accountable for doing what we said we were going to do. And I just think the program is absolutely something that I hope the rest of the country models.
Well, thanks so much for that. It's been such a pleasure working with you and your team. And as I have hopefully communicated, I think this is such an exciting project on so many levels. So congrats on all of your success and on your recent formation of the joint venture. And let's get the manufacturing facility built. Let's do it. So good luck. Let us know how we can help.
Will do. Thank you very much.